So how are we going to use these properties in order to simplify problems? Well, let's take a look at a couple examples. If you've memorized the properties, these are the properties, then all we have to do is a matter of identifying and then simplifying. So our first problem is 2 raised to the log base 2 of 7. If that matches one of these properties, we can go right to the answer. And it does. It's this property right here. So the answer is 7. The next one, log base 4 of 4 to the 13. You know, I prefer to have parentheses here. So do we have a property which helps us work with this? Yes, we do. And it's right there. So log base a of a to the r, my answer is 13. Next one is ln of e to the x times 3. Do we have a property for that? Yes, it's the property that we just used right there. Since the base of the natural log is base e, we can just jump straight to the answer, x times 3, or 3x. Next, we want to use the product and division to sum or difference properties to expand, and we want to use the coefficient property to write powers as coefficients. So let's review. Talking about these properties, a product of logs can be a product inside the log can be written as a sum of the logs. Division inside the log can be written as a subtraction of logs, and a raised to the power can be written as a coefficient. So here we can write this as a product, log base 5 of x plus log base 5 of x squared plus 1. Now, that's to the square root, or that's a square root, so we can write it as a 1/2 power. It says expand and don't use powers, so I want to change that 1/2 power, and we want to finish off the problem by writing that as a coefficient. There's nothing else we can do with this. Notice we don't have any properties on how to expand a sum or a difference inside the log. It's just products and divisions inside the log. So the next problem, we want to expand this and do so without using powers. So my first step will be to write log x squared. In this case now it's minus, since we're dealing with division. Oops, forgot my log base 6 of x minus 1 cubed. But that's using powers. I need to get rid of the powers and do the coefficient thing. So 2 times log base 6 of x minus 3 times log base 6 of x minus 1. Now, there's nothing to stop us from going backwards and going that way. Notice if we were to just follow these steps backwards, the first thing we would have to do is take those coefficients and make them powers. Then, once we have those as powers, we can go to the division step. I'm going to do this one all in one step. So in my head, I'm going to split this up as a division problem. And, well, I guess I'll do it in 2 steps. Log of the square root of that minus log, this is base 7 of x cubed minus log base 7 of x to the 4th. Now, something I want to point out, which a lot of people get wrong, is this sign here. So, notice in the original problem, both of these come from the denominator of the fraction. So both of them have subtraction here. You can think of it as, if you want, you can think of it, if you prefer, is this whole thing right here with a plus. If that makes more sense to you, it's this stuff divided by that stuff, right? So how do you connect these two together? You connect those two together with a plus. But if you were to kind of skip that step of writing it as a plus, then you would notice both of those have a negative sign. All right, now we want to do the exponents. I think that was supposed to be a y right there. And there you have it. Next, we want to go in the other direction, and we want to combine these together and write it as a single logarithm. Like I said previously, we need to deal with the any coefficients that we have first. So I have a coefficient there, so I'm going to rewrite it. Log base 8 of 9 plus log base 8 of 10 plus log base 8 of the square root of 16. So I went from a coefficient to a power. Now that I have everything with no coefficients, with just ones in front, now I can use the addition multiplication property, and we have log base 8 of 9 times 10 times the square root of 16. If you want, you could multiply that out. You know, the square root of 16 is 4, and whatever. You get a number inside there. But that's it for that one. Next one, same type of question. Write as a single logarithm. So I want to deal with the power first. That is the coefficient first. So we have this is equal to the ln of 8 to the 2/3 power minus the ln of, I don't know, some numbers. I think I'll just call this 24 because it's fewer symbols to write. 5 squared is 25 minus 1 is 24. So then this becomes the ln of, 8 to the 2/3 power is a nice looking number because it's the cube root of 8, which is 2, and then 2 squared, which is 4. So this is 4 divided by 24 here. And if you want, we can simplify that. The ln of 1/6. And if you want to get fancy, this is the same as the negative the ln of 6. But either of those two answers works just fine. For the next problem, again, we want to combine these and collapse it down into a single logarithm. Notice there aren't any coefficients, so we can just jump right to the answer. What log base are we dealing with? This is log base 10 because it's the common log. X times 9 times parentheses x squared plus 1, and all of this is divided by 5. Nothing else to do with that. We have combined it and collapsed it down to a single logarithm. Our last question uses the change of base formula in order to evaluate this using our calculator. We don't have a log base 12 button on our calculator, but we do have a log base 10, or just a log, or a natural log, that is the ln. So we're going to change base to log base 10. So I have log of my new base of the old inside stuff divided by log of the old base. If I wanted to change this to ln instead of log base 10, I could have done that. So the ln of the inside stuff divided by ln of the old base. And it is important that you pay attention to your parentheses. And when you work this out in your calculator, I'm just typing in ln of 10 divided by ln of 12 and closing off the parentheses. You get 0.9266 decimal, something else there. Now, you should be convinced that this is a reasonable answer, because if we're thinking about this as log base 12 of 10 is equal to x, what that means in exponential form is 12 to some power equals 10. Well, we know that 12 to the first is 12, so this x should be a number a little bit less than 1. So you get a quick reality check, roll for a sanity check, and decide if the number that we have makes sense. And that is using the properties of logarithms and the change of base formula to solve some problems. We're going to use all of these techniques in the next section in order to solve equations. So you definitely want to be familiar with these techniques.